trembling of a tree owing to wind. When the wind blows on a tree, it causes it to swing. This force of the wind is influenced by external factors and can tremble the tree excessively at its position, thereby uprooting it from the ground. On the other hand, the internal force is the force that helps the tree stay in place and prevents it from falling. Bending of a scale due to applied pressure. Muscular weight applied on the edges of a measuring scale can cause it to stretch. A significant amount of both tension and compression is present in the measuring scale. The external force is the muscle force acting on the scale. This force has a large enough magnitude to bend but not shatter the scale. This is because it is supported by an internal force that prevents it from breaking. Pushing a bus. Pushing a bus while sitting inside it and from outside results in two different situations. Pushing a bus while sitting inside it cause any movement in it. Whereas, trying it externally after exiting from the bus can make it move ahead, because the external pushing by the passengers introduces an outward force on the bus. The passengers, when seated inside the bus, make a cumulative system, and hence any force applied during this time does not cause any movement in the vehicle. Hence this is an internal force that exists within a system that prevents it from moving and counters the load applied by an external force. The action of a spring. When a force is applied to the spring to extend it, the spring moves. The force acting on the spring is external, whereas the internal force compresses the spring to gain back its original shape. The internal force is diametrically opposed to the exterior force, and it opposes the motion and any change in form. Pushing of a chair. Pushing a chair while sitting on it and standing on the ground gives rise to two different scenarios that can classify internal and external forces, respectively. A chair moves in the direction of the applied force when pushed by a person while standing in its proximity. At the same time, no movement is witnessed when the chair is pushed while sitting on it. Both the situations witness same amount of force applied in the same direction. The sole distinction is in the method of evaluation. The former case involves application of an external force, and hence movement in the chair is seen. In the second situation, however, the chair does not move since the person sitting in it has become a component of the system. As a result, the force acting here is referred to as an internal force. Compression of a sponge. Compression acting on a sponge body is another example of internal force. When a person rubs his hand against a sponge's surface, the sponge's shape changes. Because the person's force acts within the system, the compression force is an internal force. This internal compression force opposes motion that aids the sponge in regaining its previous shape. Tension in a rubber band. The stretching of a rubber band causes tension in it, which is an internal force. When a rubber band is tugged or stretched, the tension force is created. The original shape of the object is restored when the pull force is lifted. The force is said to be internal because the interaction occurs within the object or system. On the other hand, the external force is the force used to stretch the band and generate motion to change its shape. Wringing out a washcloth. The twisting force of torsion is used to wring out a damp washcloth. The washcloth is twisted in opposite directions from its either ends to squeeze the water out of it. Torsion is a force that twists or turns and originates from within the object. Hence it is an internal force. The collision between hockey pucks. Let us consider two hockey pucks sliding across a frictionless surface and colliding with each other at t=0. To keep the problem simple enough for evaluation, we ignore air resistance. There are three fundamental forces working on the bodies: the force acting mutually perpendicular to the ice and the hockey pucks, gravity, and the friction caused due to collisions between the pucks. Our system takes in account the two pucks only because our subject constitutes of the motion between the pucks only. Hence the frictional force between the pucks acts as internal force, because conservation of momentum is applicable in this case. When the rest of the Earth is included in our system, gravity and normal forces become internal forces as well. Kinematics of muscles and tendons in the human body. Muscles and tendons are the structures that produce the forces that cause our kinematic state to change. Muscle activity generates internal forces that induce motions of the extremities and other body components. Still, it is impossible to change the movement of the human body's center of gravity without the presence of external forces. Only when the human body comes into contact with another thing can it change its motion. Internal force research can be used to characterize particular body component motions and the nature and causes of injuries. Earthquakes and volcanic eruptions. The surface of the Earth, where humans live, is characterized by an infinite variety of morphological shapes. The narrow trenches swipe down the bottommost surface of the ocean, while the enormous abyssal plains steep it up to the seamounts and the ridges. Whereas, mountain belts to volcanic chains and hilly areas to flat lowlands range over the periphery of the continents. The generation of heat in the Earth's interior, which causes internal or endogenous forces in geology. Internal forces are responsible for all vertical and horizontal movements of the Earth's crust and some extreme calamities like earthquakes and volcanic eruptions. Frequently asked questions, FAQs. Question: what are internal forces caused by? A. One part of an object operating on other sections of it causes internal forces. Internal force is a collection of contact forces that does not cause an object's balance to be disturbed. The internal force vector's elements cancel out and hence do not contribute to the final force applied to the thing. Question: are internal forces always balanced? A. Internal forces are commonly referred to as conservative forces because they do not modify an object's overall mechanical energy. Hence they are always balanced in the case of non-deformable rigid bodies. Question: what are the four basic types of internal force? A. The four basic types of internal force are: compression, the material gets squeezed under this force of push. Nature. Tension, the material flexes under this force of pull. Nature. Torsion, the material experiences a twisting force, i.e., turning force. Bending, the material loses its straightness and bends. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.